There it goes. All right, two-dimensional figures. What in the world is that? Well, I'm glad you asked, because I'm here to answer it. Say what? Flag? I don't know what she's saying. Flash? Flag? Flat. Oh, flat. Well, this would be just one dimension, right? Because it only goes in that direction, I guess. But I'll show you. I'll give you some examples. So, circle. Circle is a two-dimensional figure, all right? Now, three-dimensional, like two-dimensional figures, anything you could write on a flat surface, basically, okay? So, yeah, that would be a two-dimensional figure. But if it came out of it, right, if I drew something but it came out, that would be a what kind of? Three-dimensional, okay? This is just all two-dimensional stuff. So, circle. What is a circle? Let's write down this definition. We're going to use circle. In fact, we're going to have a chapter later on in the year. The whole entire chapter is just about circles, all right? So this is the first time we really talked about a circle, and we'll give you a little bit of stuff about a circle. But we got a whole entire chapter just about circles. All right, let's keep going. So it says it's the set of all points in a plane of all points in a plane a given distance, this definition right now is not going to make much sense, but when we draw the circle and we talk about it, then it should kind of make sense. A distance from a given point, which we call the center. So the given point is called the center of the circle. All right, so let's talk about that. All right, so let's have a given point right there. That's my given. I tell you what, I'm going to do this. I'm just going to draw the circle, and then I'll put the point on there in a second. So here's a circle, nice circle right there. Scooch it up a little bit. See that dot in the middle right there? That's the what? That's the center of the circle. Okay, put it right there where that dot was. That's the center of the circle. What does that mean? It says the set of all points in a plane, in a flat surface. A given distance from a given point. So here's a given point. There's a given distance. Now watch. What if I did that? I could do this all day long, couldn't I? And what's true about every single length of the line segments that I'm drawing right here? They're all the same. They're congruent to each other. Good. Okay? Looks like a peace sign. You guys don't even know what a peace sign is, do you? Back in the 60s and 70s, peace signs were everywhere. All right, you get the idea? All right, if I drew a whole bunch of these, then it would look like a, oh, what's that game? No, Trivial Pursuit. You probably never heard of that, have you? Have you heard of Trivial Pursuit? Back in the 80s and 90s, it was a huge game. It was a trivia game where you got these cards and you ask questions that had the answers on the back. Anyway, they had these little pieces that you go around the board and that look like that, and you try to put all the pieces into your little pie, and then once you get them all in, then you win. Anyway, just doing old man stuff, just telling old man stories, okay? So here we go. So that is a circle. And what do we call the, what do we call that dot in the middle again? This one right here? That's the center of the circle. Let me put that in a different color, so I'll put a little arrow. That is the center of the circle. Do you see all those distances that I drew? Each one of these distances are exactly the same if it's a circle. If it's a circle, every one of these distances are exactly the same. That's the given distance from a given point. Everybody see that? So that given distance, we have a name for that as well. From the center to any point on the circle, this is called on the circle, like around the edge of it like this. That's on the circle. Like right there, that is not considered on the circle. The circle is the white curved line around it, okay? It's not inside it. That would be inside the circle or the interior of the circle. So this is the circle itself, okay? Does it make sense? So this is on the circle. Is that on the circle? No. All right, it's not like it's a plate or a dish or something. It's not like you cut out a cardboard circle and you say, oh, if I put a point right there, that's on the circle. It's not. It's in the circle. This is outside the circle, or the interior, exterior. This right here is where? On the circle. Everybody got it? Okay. We have a name for this, and I'm sure it's a word that you've seen before. It's not just a geometry topic for like 9th or 10th grade geometry. It's something you've learned from, I don't know, at least middle school. What do we call that? That distance from the center to a point, any point on the circle. It's called the radius. Very good. See, I knew you've learned this before. All right, and to tell you the truth, that's all we're gonna say. I don't think they talk about the circle anymore. Yeah, we're gonna learn a whole lot more about circles, believe me. All right. But that's all we need to know right now, that this is the center and this right here is the radius of the circle. You also have a diameter of the circle. You got circumference of the circle. There's a bunch of stuff we can learn about circles, and you've probably learned about those yourself, haven't you? I think at the end of this lesson, which I don't know we're going to get to today or not, but at the end of the lesson, they do talk about the circumference and area of a circle. So. The distance around the outside of the circle, yes, or the distance around. So the length from here to here, if I was a string and I was to pull it out and measure it, yeah, that would be the circumference of the circle, all right? But for right now, we're not going to do that. We're going to talk about some other two-dimensional figures, okay? I don't want to dwell on circle any more than that. Everybody good? All right. Let's do another one. Let's talk about this. We're going to talk about this a whole lot. This is a word we're going to use a lot. Here we go. First time you've heard it, maybe, I don't know. It's called a polygon. Has anybody heard that? Yes. Okay, it basically means many angles. That's where that word comes from. All right, many angles. And we're going to do a whole bunch of different polygons. So for instance, let me find a polygon tool, click this. I can put how many sides. Like right now it defaults to 6. I'll put OK. And this would be considered a polygon. Now, what does it mean to be a polygon? I'm not going to really write the definition down. I will write a couple words down. A polygon is a simple closed curve. Now they say curve. When we think of curve, we think like a circle, right? Around an arc, right? Or smooth, kind of like that. Well, a curve just means it's just all attached, right? And it's not open, right? So it's not like one of those sides don't come to a point. It's not like if it came like this, that would be open, that would not be a polygon, all right? So it's got a certain amount of sides. What's the least number of sides that a polygon could have? Like if it was going to be closed, what would it be? Nah, that wouldn't be a polygon. A polygon or a circle's not considered a polygon. What do you think? 3, right? 3 sides, which is a what? A triangle. We're going to talk about that in a minute. But so the most you can have is 3. What's the most number of sides you can have on a polygon? 12. You can't have 13 sides. You can't have 20 sides. You can't have 100 sides. An infinite number of sides. You can have as many sides as you want, all right, to make it a polygon. Right? Now, we have certain names. You're probably thinking we have certain names that we call certain polygons, and normally we just go to 12. I think there's one for 20, but that's what it is. So let me read it again. It says it's a simple closed curve that consists only of segments. So it's not a circle. Segments, line segments. Each of these are line segments. And each segment I didn't really write that the way I wanted to. So we'll just say that. So but they all connect. There's no opening. There's no gap. Okay? It's closed. That's what they mean by closed. All right, so let's talk about a couple words here. Those segments that are all connected are called the sides of the polygon. So that's a side. So how many sides does this one have? 1, 2, 3, 4, 5, 6. Okay? Now, I drew one that all the sides are equal in length. They don't have to be equal in length. Okay? That's just the way I drew it. You could draw it all crazy looking, but as long as they're connected, you're good to go. Notice the endpoints. This is what I was going to say earlier. See the endpoint of that segment? And what about this segment right here? Do you see how that connects at a common endpoint? We give that a name, and if you look at it, it kind of looks like something we've talked about, doesn't it? That goes that way, that goes this way. It looks like a what? An angle, and it is an angle, right? And where does the angle come together when they share the endpoints? At the vertex. So we're going to use that word again. So that vertex word is used right here as well. So that's a vertex. So that's pretty important as well, all right? Let's get a little bit more specific about polygons. Now that polygon right there, the way the computer made it, they made it where all the sides are equal and all the angles are equal. Okay, I'll tell you what, I'll just put that word in here. So if all the sides are equal, if you have a polygon and all the sides are equal to each other, here's the word we use. We call it an equilateral. Probably haven't heard that one, have you? Have you heard it? Okay, good. So it's called equilateral, which means what? Lateral means sides. That's what lateral means. Okay, of course the equa, where do you think that is? It's equal, right? The same number. So it's equal number of sides. So if it's an equilateral polygon, then all the sides are equal. What if all the angles were equal to each other? What if all the angles were equal to each other? Very good. That's exactly right. We call it equiangular. Okay, it's an equiangular polygon. And you definitely see those two words, don't you? You see the equa, and you see the angular, which means angles. There you go. Now, here's another thing. What if you had something like this thing right here that I've drawn? Okay, so both of those things are true about this, right? All the sides are equal. If I was to measure it, every one of these sides would be the same. So it's equilateral. If you also measure the angles on this particular one right here, if I measure this angle and this one, and so on, what would you find is true about every single one of those angles? They're equal to each other. So it's equilateral and it's equiangular, and so we call that a regular polygon. I was hoping for something a little more interesting than just the word regular, but that's, oops, if I can write on this thing, it's a regular polygon. So what's a regular polygon? It's when you have a polygon that has all the sides, what? Equal, all the sides are equal, and all the angles are equal, okay? When all the sides are equal, when all the angles are equal, that's considered to be a regular polygon. Later on, not in this chapter, but later on, we're going to deal a lot with regular polygons, and there's going to be a lot of stuff that we're going to know about regular polygons. We're going to have all these different types of polygons. But the word regular, I think, is very important, okay? They're just touching on it right now. They're just hitting it, boom, jumping off of it, and then we're going to talk about it later on. All right, I'll stop with this next little part right here. And this is stuff you probably already know. This is called classifying or naming, right? That's what you do when you classify something, you name it, polygons. So we've got some polygons and we got some names for the polygons. So let's do this. Let's figure out how many sides that we have on our polygons. So what did we say was the smallest number of sides? 3. So what do you think the name is for a 3-sided polygon? A triangle, you got it. Okay, so it's a triangle. That's a 3-sided polygon. We all know that one, you know triangles. Now this one, let's see if you get this or not. What if you had 4 sides? What's the name of any 4-sided figure? Oh, see, you guys are so smart. Did you learn all this last year? When did you learn all this? In middle school? Ms. Larson? Good. Well, she's doing a good job. So this is called a quadrilateral. A lot of people, what were you going to say if you didn't say quadrilateral? Some of you guys. Right. Some people are going to say square. Some people might say rectangle. Okay. Those are quadrilaterals. But the general word for a 4-sided figure is a quadrilateral. Quadrilateral. We already said sides is lateral means sides. What does the prefix quad mean? 4. What does the prefix tri mean? 3, and so on. Yes. Everything that I write up here. Anything that I write, you can write. I'm writing it too, right? Yep. I'm going to write them all. Okay? Let's finish it up. It's not going to take that long. What about 5 sides? Anybody know what that's called? No, it's penta. Pentagon. All right, penta means 5. All right, 6, we just drew one. We just drew a 6-sided polygon. It's called a hexagon. This is a hexagon. Hexagon. All right, so hexa means 6. Now 7's a little weird. We don't use 7 very often, but they call this a heptagon. And if I remember right, I've heard some people call it a septagon. I don't know. You can double check on that. I don't know if that's 100% true or not. Okay, but this one calls it a heptagon. I taught of it in another book, and I guess they didn't like this word, and they just called it a 7gon. Right? They just put a 7 in front of gon. Whatever. 8. 8's something you see every day, probably, if you're on the road, if you're outside. It's an octagon. What octagon do you see every day? Stop sign, right. It's octa, O-C-T-A, and then gon. Octa, that's 8. Octopus, right? 8 arms or legs or whatever that thing has. Do they have arms or legs? I don't know. Tentacles? Okay. I was trying to make it easy. What about 9? That's kind of a weird one. They call this a non-agon. Just make sure it's non-agon. I guess that's the prefix for 9, okay? Or they couldn't come up with anything cooler than that. All right, it's not a tenagon. How many years is 10 years? Or what do we call a 10-year span? It's a decagon, or it's a decade. So we call this a what? A decagon. So decagon. I do. As soon as we only got 2 more to do. Well, 3 more, kind of. So 11. 11's a weird name. I would not have known this name unless I looked it up and have it in my notes, okay? So I don't know. Does anybody know what the prefix for 11 is? It's a hen decagon. Is that what you said? Did somebody say that? Or you just looked in the book? I've never heard that before, but that's what they call it. 12, I've heard before, and they call this a dodecagon. My guess is this is probably like from like the Latin or something like that. All these prefixes is my guess. I'm not a Latin person. I don't know. Did anybody go to Tall Oaks or did you go to, yeah. Are these prefixes? Okay, they probably are. It's kind of my guess. It usually is. And then after that, we don't really have any names. N represents any number of sides, okay? Because somebody said 12 was the most number of sides we could have on a polygon. Well, it's the most that we name, right? After that, you just call it an n-gon. You wouldn't really call it n. You would say what? Like if you had 17 sides, what would you call that? 17-gon, right? I probably wouldn't even call it anything. I'd just say it's a polygon with 17 sides. That's probably what I would say. Does that make sense? All right. So, yeah, I think that's good. Still got a lot more to go on this. I do have an A and a B. So I don't know how far the A goes, but I'll show you. Is that what I had on, let me take a look at my lesson plans. Because sometimes I write stuff on my notes that are different on the lesson plans. So today, I just said we're going to read for a quiz. No, yes, that's right, class. Oh, yeah. I did say we're going to have a quiz tomorrow. Let's push that a day, all right, because I forgot all about it. I should have looked at my own lesson plans that I wrote up, okay? So, because I have I got this split in 2 days anyway, so I'm not sure how far I got, but I will put it on here. So here's your homework. Try and get this thing to write. There we go. Here's your homework. So it's section 16A. Now, listen to me. Everybody listening? I am not sure because I don't have the book in front of me and the bell's just about to ring, so do as many of these as you can, all right? That's what I'll say. Do as many of these as you can. If you get to a point you're like, oh, we didn't talk about that stuff, then don't do them, okay? Just do the ones that we've talked about in here, all right? So we'll call it 1-6A. So 13 to 20. I have an idea. I have a feeling that 31 to 43 we haven't gone over yet. My guess is we've probably talked about 13 to 20. Okay, so at least do 13 to 20. I probably won't collect it tomorrow, but I will go over the quiz. We'll take the quiz on Thursday. All right, and I'll kind of tell you. Yeah, it was supposed to be tomorrow, Wednesday. I just forgot to look at my own lesson plans. That was silly. All right, there you go. Wait for the bell to ring, then you can go. Have a seat, though. Have a seat.